Hello guys, so today we are going to be learning about the Solvay process. It's actually an industrial process in the manufacture of sodium carbonate. So let us see how it starts. So first I've written the name there, Solvay process. I've also written the raw materials that are required for the Solvay process. So let us list them down. So first we have something known as the ammonia gas. I'm just going to write the formula since it is easier. We have the ammonia, we have then the concentrated sodium chloride solution. So I'll just write there concentrated sodium chloride solution, the concentrated sodium chloride solution, or if you don't want to call it that, you can call it brine, which is still fine. Then next we have limestone, which mainly consists of calcium carbonate. Then we have coke. Coke is an amorphous form of carbon, so we are going to be writing coke there. Lastly, we have water, which is also something that is not mainly used in the Solvay process, but it is mainly applied in cooling. So after that, we are now going to start. We are just going to start with the chambers. You know, all these raw products have to pass through the chambers. I won't be able to list them due to time, but for now let me just start doing the process, which is referred to as the Solvay process. So let us start with the first one, which is the, sorry if you cannot see, there we go. So I'm going to start with the ammoniacal tower. So the ammoniacal tower is usually the first chamber of actually the first chamber of the Solvay process. You can see I've written it well there. So now what happens in the ammoniacal tower is we'll simply take the ammonia gas and then we mix it with the brine or the concentrated sodium chloride solution, and we get the ammoniacal brine, and there is its formula. So I'm just going to write here on the side ammoniacal brine. If you're not good with the formula, then you can also do word. There we go. So next, after we are done with the ammoniacal tower, we are going to be going to something known as the kiln. The kiln, yeah, this is actually a chamber where strong heating is done. So in this where this strong heating is done, the coke which was used here is going to be applied in this chamber. So coke, which is an amorphous form of carbon, we add it to oxygen gas and we get carbon 4 oxide gas. So this carbon 4 oxide gas generated will now be taken to the Solvay tower, which is where most of the processing, or most of the chamber where most of the work does. So during this oxidation process, it will generate a lot of heat energy, and when it generates a lot of heat energy, it will now decompose this calcium carbonate, which is the limestone that was also here. I wrote it somewhere here. Yes, you can see it there. Calcium carbonate is now going to decompose. This is calcium carbonate. It's a solid. It's actually an insoluble salt, so it's going to give us calcium oxide, which is also a solid, and carbon 4 oxide gas. So we can see that we have two sources of carbon 4 oxide gas, where coke, which is an amorphous form of carbon, is being oxidized into carbon 4 oxide gas, and the generation of heat energy is now decomposing the calcium carbonate into calcium oxide and carbon 4 oxide gas. So guys, we are done with the kiln. So let's now go to our third chamber. The third chamber is known as the Solvay tower. The Solvay tower, or if you don't want to call it that, you can call it the carbonator. So yes, so this is now where most of the important industrial process is going to occur. There's majorly a diagram that you're supposed to draw here where the ammoniacal brine from the ammoniacal tower is going to enter through the top, but we are not going to get into that now. So first of all, we are going to start with the main two equations that we're supposed to know here. Remember guys that these two equations are what are going to assist us further when we are going to be discussing the Solvay process. So now let us start with the first equation. So in this first equation, we are going to form something known as the ammonium hydrogen carbonate, where we'll be reacting the ammonia gas with the carbon dioxide that has entered from the bottom, and we'll also react it with some water so that it can give us the ammonium hydrogen carbonate. So this will be the equation. The ammonium added to the water and carbon dioxide gas. So remember guys, you have to write set symbols since they are very important, and you are going to obtain ammonium hydrogen carbonate as your solution right there. So guys, that is the first equation that you're supposed to be knowing in the solvator or the carbonator. That is the first one that you're supposed to be knowing. So now after this, there is something we are going to do here that we learned in salt, which is called the precipitation method. So it's actually very simple. It's like we're going to be writing an ionic equation, but we will not be suspending the ions for real. So for those who do not know how to write the ionic equations, you can subscribe to the next video that I'm going to remove sooner or later, so that I can teach you how to write the ionic equations for various insoluble salts. So now let us now write our second important equation. So we will take the ammonium hydrogen carbonate, which is aqueous in nature, and we will add it to the sodium chloride. Remember that the brine and the ammonia are now being separated when we are coming to the Solvay tower, so that we can now be able to form our products there. So we know that the sodium chloride, when it's still concentrated, it's going to be a solid, so it's going to give us ammonium chloride, which is aqueous, and we are also going to get the sodium hydrogen carbonate. Yeah, there we go guys. So you see that all you have done is exchanged the anions. The anions are simply the negatively charged ions that are found in both equations. So the hydrogen carbonate anion, that is actually a radical, is now being taken over by the sodium, while the chlorine has now been taken over by the ammonium ion. So guys, that is the most important thing that you're supposed to know in the solvator or carbonator. It does not really have a lot of explanation, but all you have to know is how to work, to know and to write the equations, how to exchange the anions, and you will get your product. So we are now going to the fourth chamber of the Solvay process, which is referred to as it is called the filtration chamber. So we'll just write here the filtration chamber. So guys, what's going in this chamber, we know that at the Solvay tower, after the exchanging of the valencies, we have seen that we have gotten ammonium, we have gotten the ammonium chloride, which is an aqueous solution, and we have also gotten the sodium hydrogen carbonate, which is a solid. So guys, when you want to separate these, we can see that we have an aqueous and a solid solution there. So what you're simply going to do is we are going to separate these using filtration. So we'll just filter the mixture there. After filtering the mixture, we see that we'll be able to obtain the sodium hydrogen carbonate as the residue. It's going to obtain it as the residue, and we're also going to obtain the ammonium chloride as the filtrate. So guys, there you have it. It's just that simple. We only have to apply the basic knowledge of the simple classification of substances as we learned in our first form of how to separate these two mixtures. So after that, we are now going to the fifth chamber of the Solvay tower, the Solvay process, which is known as the roaster. The roaster. If you don't want to call it roaster, you can call it the roasting tower, depending on how well you're going to understand it. So guys, so here in the roaster or in the roasting tower, this is now where the sodium hydrogen carbonate and the ammonium chloride, after being separated, this is now where we will obtain the main product of using the Solvay process. That is the sodium carbonate. So what we are going to do is we are simply going to decompose the sodium hydrogen carbonate in the presence of heat. So we'll decompose it so that we can able to obtain sodium carbonate. We'll also obtain water in the process, and we will also obtain I think mainly it is those that are the products there. If I'm missing anything out, you can inform me, but mainly I think that there should be some carbon 4 oxide gas that is involved there. Yes, so that we can be able to see. Okay guys, let me confirm to see if I'm right or I'm not. So just a short while. No, it's better if I confirm so that I don't be showing you things that are incorrect. So let us see. Yeah, so the equation is right guys, as you can see there. It's actually the sodium carbonate, the water, and the carbon 4 oxide gas. Remember always to write the state symbols in any scenario that you're going to be using. So we are now going to the sixth chamber, which is known as the slaker. If you don't want to call it the slaker, you can call it the slaking tower. So guys, in the slaking tower here, oh sorry, we forgot to balance the equation that we have been given above. So we'll just simply put a 2 on the sodium hydrogen carbonate, and it's going to be balanced as from there. So we are now be getting into the slaker or the slaking tower. So this is slaking is actually dissolving of calcium oxide in water. So if you want the general name of dissolving calcium oxide in water, it's simply slaking. So we'll just take the calcium oxide, which is a solid, and add it to water. We'll just add it to water, which is a liquid there, and we'll be able to obtain our calcium hydroxide solution. So calcium hydroxide is basic in nature, and we also have to acknowledge and appreciate that calcium hydroxide is an aqueous solution. So guys, we are finished with that part. So now we are going to the last and the final chamber of the Solvay process, which is referred to as the ammonia generator. The ammonia generator. Ammonia generator. So guys, in the ammonia generator, what we are going to do is very simple. We'll just take the waste products. Guys, I forgot to mention that the waste products here are the calcium hydroxide solution and also the ammonium chloride that we left up there. So those are the main waste products. So what we are going to do is, guys, we are going to react them together and we are going to get a waste product. So we're just going to take the ammonium chloride, which is an aqueous solution. We add it to the calcium hydroxide, which is also an aqueous solution, and we are going to obtain calcium chloride, which is a solid. We'll also obtain some ammonia gas in the process. So ammonia is a gas, and we'll also obtain some water. So guys, in this process here, as you can see in the product side, we have gotten ammonia gas and water. So these waste products here, we can see that the waste product here is calcium chloride. The ammonia and the water are going to be recycled back here at the Solvay tower, where they are going to be used in the manufacture of ammonium hydrogen carbonate. And here we know that our calcium chloride is now our waste product. So guys, we know that it's actually a must we balance this chemical equation, though it is long, but it is actually a very simple and very easy equation to balance. So guys, we're just only going to add a small 2 there in the ammonia gas. Then we are going now to test to see if it's actually balanced. So we see that we have we also have to add something to ammonium chloride so that we can make the nitrogens balance. So we see we have 2 nitrogen both sides. We have 8 plus 2, that's 10 hydrogen. 6, what is 6 plus 2, that's 8. So guys, this kind of a mistake there. You see that we have 8 on the other side and we only have 2 on this side. But anyway guys, I know that the people who are able to balance this well can be able to balance the equation with ease. So guys, let me just confirm on how it is balanced, and I'm getting back to you in a while. So let's confirm. So guys, we only forgot, we were this close to getting it right. So we only have to add a 2 in water, and finally the long equation is going to be balanced that way. So you can see this is how we balance this equation. So we also have to know the uses of this waste product. So I'm just going to write the uses of calcium chloride. So guys, the uses are very simple. So one use that we are going to have here is it is used in extraction of sodium from sodium chloride. So guys, that is one use. It actually has 2 uses. So the second use here is going to be that it is used in defrosting ice. It is used in defrosting ice on roads. So mainly why we are saying this is because one, the main reason why it is used in defrosting of ice is because it is actually used as an impurity, and it lowers the melting point of the ice that is going to be used there. So guys, we are done with the Solvay tower. So the only thing that is we are done with the Solvay process. So the only thing that is remaining for us to do is just to simply write the uses of the product which we were aiming to obtain, that is the sodium carbonate. So I'm just going to write here uses of sodium carbonate, So mainly guys, it only has 3 uses. The first one, it is used in manufacture of glass, So the second one, it is used in the manufacture of detergents. So the type of detergents that we are talking about are like the soap and all the others, the manufacture of detergents. And the last one is actually the it is used in softening of water. Softening of water. So guys, thank you for being with me throughout the video. I hope you enjoyed it, though it did not come out as I expected it to come out, but I hope that it's going to help you to understand the Solvay process well. Please like, share and subscribe so that you can continue getting more content. Goodbye.